Firefighters in Alaska and the Lake States have been following the trend of the Buildup Index for years, using it to assess season severity and landscape flammability. In this presentation, we will examine how it fits into the Fire Weather Index system, some important thresholds and interpretations, its seasonal trends, and how it compares to the energy release component from the NFDRS system. As the second intermediate fire behavior index, the Buildup Index, or BUI, combines the influences of the Duff Moisture Code and the Drought Code. The Buildup Index, similar to the Duff Moisture Code, is an indicator of how well fires may burn during the growing season. The Buildup Index typically starts low in the spring and may rise to as high as 200 under extremely dry fire seasons. It can indicate the depth of ground fire, fuel consumption, and mop-up problems in deep organic fuel beds. At 40, heavier fuels just begin to burn. As mentioned earlier, the BUI can be a good way to compare one fire season to another, identifying periods that can support significant fire growth, as well as season-ending conditions. This plot shows the Buildup Index and its two component parts, the Duff Moisture Code and the Drought Code, for the 2015 season at the Hogatsa RAWs in Alaska. The black dashed boxes highlight the two periods of significant growth on fires near the Hogatsa weather station. Notice how the BUI shadows the DMC for much of the early season, diverging from it only once the Drought Code reaches higher levels in July. In this example, the BUI is as much as 40 points higher than the Duff Moisture Code in the late season when drought conditions influences. These graphs show the relationship between the three Fire Weather Index outputs, the Duff Moisture Code, the Drought Code, and the Buildup Index, and MODIS detections from 2001 through 2013. MODIS fire detection records identify when and where much of the burned area occurred over the last 15 years in Alaska. In a recent study, these detections were associated with the Fire Weather Index records from the nearest RAWS station on the date of each MODIS fire detection. As shown, the Buildup Index demonstrates powerfully its ability to predict increasing likelihoods of MODIS detections in Alaska. Over a 20-year period, combining all the stations in the Yukon Flats predictive service area, this graph shows the climatological average of both the Duff Moisture Code in orange and the Buildup Index in green for the whole fire season. Independently, two separate datasets characterize seasonal trends in area burned. The shaded bars identify the median weekly number of MODIS detections in the same Yukon Flats predictive service area. The gray shading in the background depicts the normal range of area burned based on weekly summaries from the Incident Management Situation Reports for Alaska wildfires. These two separate sources of area burn data both show how well the BUI represents the seasonal potential for fire growth. Forecasting the Buildup Index out for weeks or entire seasons could provide important insight into fire management decisions made both before and during the fire season. In this example, climatological trends for the Buildup Index and the energy release component for Fuel Model G at the Spinchich Lake RAWs in Michigan are compared. While ERCG shows a generally flat average trend throughout the growing season of June through mid-August, BUI shows it rising, recognizing the influence of drought conditions that can become severe in July and early August. In this example, the Duck Lake fire near the Spinchich Lake RAWs, shown in the last graph, burned more than 20,000 acres in a single burn period under hot, dry, windy conditions on May 24th in 2012. This graph of BUI and ERCG at the Spinchich Lake RAWs highlight the seasonal trend for the 2012 season. Buildup Index and its 90th percentile threshold are shown in orange, while ERCG and its 90th percentile threshold are shown in green. While both ERCG and BUI were crossing the 90th percentile threshold on May 24th, the buildup index signaled a drying trend that began only a couple of weeks earlier. ERCG instead suggests that the season severity had been elevated all spring. Similarly, the buildup index for 2015 at the Hogatsa-Raz showed significant departures from the normal trends shown in blue, setting new records, the two red lines converging in late June and early July, and again in late July and early August. The buildup index ability to track periods of large fire growth make it easy to identify thresholds that help interpret its current value. This photo demonstrates the seriousness of the situation around the Hogatsa-Raz in late June, with massive lightning storms igniting record numbers of wildfires that grew out of control into early July. Nearly 5 million acres burned over less than 3 weeks. Again, like the spinach plot earlier, this plot shows both BUI and ERCG from the 2015 season at the Hogatsa-Raz. It shows buildup index building toward and peaking on July 6th when fire growth was extreme, while ERCG peaked much earlier and had leveled off by that time. Though the trends are very similar for the two indexes after July 1st, it is much easier to identify thresholds for significant fire activity throughout the year using the buildup index. The buildup index, or BUI, is well known among firefighters in Alaska and the Lake States. It combines the Duff Moisture Code and Drought Code into an index of fuel availability. The buildup index begins the year at low levels, assuming that Duff and drought fuels will be saturated in the spring. It is a good indicator of growing season landscape flammability. Plotting the current year's buildup index trend against climatological normals highlights the season's severity. And those same individual year plots can show past periods of significant fire potential as well as season-ending weather patterns. Take the time to view the other fire weather index system lessons and become familiar with what a system can tell you.